In this lesson, we're going to learn about the last power rule. It is raising a power to a power. So before we get started, let's do a recap on the product rule and the quotient rule. Remember, when we are multiplying like bases that are the same, we are simply going to add the exponents to turn it into one factor. So we have two factors of x here, but once we simplify it, we have one factor. So our first example of the product rule was a squared times a to the third. If we write this together into a single factor, we have a to the fifth because we have two a's being multiplied by three more a's. So you just add the exponents. Then we have the quotient rule, which is the inverse of the product rule. When we are dividing exponents that have the same base, we can rewrite this expression into a single base of x by simply subtracting the exponents, the top exponent minus the bottom. In this example, we have b to the sixth divided by b to the second. We can put this expression into a single factor of b by simply subtracting 6 minus 2, which gives us 4. Okay, now let's take a look at the power rule that is known as power to a power. So we have x raised to the m power, which is all raised to the n power. So a power raised to a power. We can simplify this by simply multiplying these exponents. So again, let's show why this is. In our first example, we have 4 x squares being multiplied. So we have x squared times x squared times x squared times x squared. Now let's expand each of these x squares. We have x times 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 x. So now we can put this all together and we really have x to the 1, 2, 3, 4, 5, 6, 7, 8th power. So you can see that 2 times 4 is what gave us 8, and this is why. Now, in our next example, we have 2 squares. So we have 2 squared times 2 squared times 2 squared. Now we're going to expand each of these. 2 times 2 times 2 times 2 times 2 times 2. So this really gives us 2 to the 1, 2, 3, 4, 5, 6th power. Okay, let's do these together. This time, we're only going to apply the power rule. We're not going to write it out. In this first example, we have x to the 0 raised to the second power. We simply multiply. We have a factor of x, and 0 times 2 is 0. We will never leave a factor raised to a 0. We will always convert it to the 1. In this example, we need to be very cautious because this power or exponent of 3 is applied to every factor in the parentheses. This includes this base of 2. It has an understood exponent of 1. So now we're going to multiply this 3 times every exponent of each factor within the parentheses. So we have a base of 2 now raised to the third power, a base of m now raised to the sixth power. We can go ahead and determine what 2 to the third is. That is 8, and then it's times m to the sixth. In this example, we have 2 factors, therefore we have 2 exponents that we will multiply the 4 times. Remember, everything gets multiplied, every exponent. So this is x to the negative 8 times y to the 12th. Again, we're not going to leave a negative exponent, so this x factor will flip or reciprocate to the denominator and become a positive 8. In this last example, we have 1, 2, 3, 4 factors. So we have 1, 2, 3, 4 exponents. So we're going to multiply the negative 3 times every exponent, including in the denominator. So we have 2 to the negative third times a to the negative 12 over 3 to the negative third times b to the negative 6. So all we did is multiplied each exponent by this negative 3. Now, let's move some things around. The two top factors are negative exponents, so they will flip to the denominator, making them positive. And then the two bottom will flip to the top. Now let's go ahead and simplify 3 to the third, which is 27, times b to the 6th over 2 to the third is 8 times a to the 12th. Okay, pause the video. When we come back, we'll do these together. Okay, I'm going to write in my 1 here. I'm going to have 2 to the third times a to the 6th. So this is going to be 8a to the 6th. In my second one, I am going to have g to the 12th over 2 to the 6th times f to the negative 9. We're going to bring f to the numerator, make it positive. I'm going ahead and evaluate 2 to the 6th, which is 64. In my third problem, I'm going to add in my understood 1 exponents. I have 6 to the negative 2, m to the negative 2, and n to the positive 6. So the 6 and the m factors need to be moved to the denominator. So n to the 6 stays in the numerator. We have 6 squared times m squared. And then if we evaluate, we get 36 times m squared. Okay, number 4, I want to add in all my understood 1 exponents. We're going to have 4 to the negative 2 times a to the positive 2 over b to the negative 6 and c to the negative 2. Let's move things around. So 4 to the negative 2 is going to go to the denominator. A squared stays where it is. These two factors in the denominator will move to the top and become positive exponents. And then now let's go ahead and simplify 4 squared. Okay, now let's look at just a couple of problems where we're going to combine all of the rules, the product, the quotient, and the power to a power. So here we have several factors, E and F. So I have some E exponents on the top and then on the bottom. And I have some F, bases of F, top and bottom. So we can do this several ways. We could just go ahead and distribute the 3 to everything here, every exponent. Or we could go ahead and combine some things within here first. So I think that's what I'm going to do. So on the top, I can apply the product rule. So this is going to give me f to the 5th. In the denominator, I can apply the product rule to the e factors. So that's going to be e to the 1st, and then I have the f to the negative 3rd. And now before I distribute the 3, I still have 2 sets of e's and a set of f's. So I'm going to apply the quotient rule. So I have E, 4 minus 1 is 3, and then F, 5 minus negative 3 is 8. all raised to the third power. Now I'm going to go ahead and distribute the 3 to each of these, and I have e to the 9th and f to the 24. We could have distributed the 3 to everything first and then use the product rule and the quotient rule, but I like this way better, but it's up to you. So let's do one more like this together. I have some missing understood ones. So let's look on top. I have a couple of n's. I can use the product rule in the denominator. I have a couple of m factors. I can use the product rule. So that's what I'm going to do. So in my numerator, I have an m to the first. I can use the product rule on these n's, and I add them and get a 3. In the denominator, I use the product rule on the m's, and I get -5 when I add those. And now I'm going to use the quotient rule. So we have 2, and then 1 minus -5 gives us m to the 6th power. And then I have a factor of n. 3 minus 8 is -5, all raised to the power of 2. Now let's distribute this 2 to every exponent, and then we'll adjust our negative. So we have 2 squared times m to the 12th times n to the -10. I'm going to evaluate 2 squared, and I'm going to move n to the -10 to the denominator. So I have 4 m squared all over n to the 10th. Now you pause the video and you try these. Okay, on the first one, I'm going to combine my a's using the product rule and the b's in the denominator. I have a squared times b to the -2 over a to the -2 times b to the 5th, all raised to the 2nd power. Now we can apply the quotient rule. I have a to the 4th because it's 2 minus -2. And then I have b, -2 minus 5 is -7, all raised to the 2nd power. I'm now going to multiply by the 2. I have a to the 8th and b to the -14th. We will rewrite the b, put it in the denominator, and make it +14. Number 2, I'm going to combine my k's and then my p's down here. So in the numerator, I have k squared times p to the 4th. In the denominator, I have k to the 4th times p to the 5th, all raised to the 3rd power. Now let's use the quotient rule. So I have k, 2 minus 4 gives me -2, times p, 4 minus 5 gives me -1, all raised to the power of 3. I'm going to multiply the 3 times each exponent. I'm going to get k to the, start over. I get k to the -6 times p to the -3. Both of these need to be moved to the denominator, so we'll need a 1 in the numerator. And we are done.